Okay, in lesson 17, we are continuing working with quadrilaterals, and today's focus is we're going to be working with parallelograms. Question 1 was already done for us, but I want to go ahead and go through so everybody understands what they're explaining here. And it says angle A measures 60 degrees. Extend the rays of angle A and draw a parallelogram A, B, C, and D. So what they've done here, as you can see, is they've identified the various vertices A, B, C, and D, and it has a parallelogram. So that's how they're naming this parallelogram A, B, C, and D. So they're telling us angle A right here is 60 degrees. Now what we know about a parallelogram is that opposite angles are equal. So that allowed them to say that, well, that means angle C will be 60. Now another thing we learned in class is that adjacent or angles next to each other have to add up to be 180. So if C is 160, that means D would have to be 120, so they would add up to 180. And we can check that because A plus D, which is 60 plus 120, would also mean 180. Now, that also let us know that B, since it's an opposite angle, would be 120. So that's how they came up with their measurements. Now, question 2 says WXYZ is a parallelogram not drawn to scale. Using what you know about parallelograms, give the measure of sides X and Y and Z. So, what we know about a parallelogram is that opposite sides are equal. So in this case, where I can see, let me get up here, this side right here is 6 centimeters. That means opposite side is 6 centimeters. So that means that segment XY is going to equal 6 centimeters. Now YZ, which is on right here, and we can see segment XW is 3 centimeters, so opposite sides are equal, so this one would be 3 centimeters. So line segment YZ is equal to 3 centimeters. Now under B, they're telling us angle WXY equals 113 degrees. So we're saying, and I'm going to change colors here so you can see. Trying to change colors anyway. Maybe I'm not going to be able to. Nope, don't look like it's going to let me change colors. So when they're saying angle W, which is right here, X, which is up to here, and Z, XYZ, oh, excuse me, I'm sorry. No, they're saying WXY right here is equal to 113 degrees. Okay. Now, one thing we know is the opposite angle, which would be angle YZW, which happens to be right here, is the opposite one. So it's going to equal 113 degrees also. So this one's going to be 113 degrees. Now, for angle XYZ, which is XYZ right here, we know that the sum of angle Z, which equals 113, and the angle Y has to equal 180. So if I take 180 and subtract the 113 from it, we can see the angle Y has to be 67 degrees. So there's 67 degrees. Now the last one, they're saying ZWX, which is the opposite angle. That makes that one's going to be 67 degrees also. 3. Jack measured some segments in problem 2. He found that segment WY equals 8 centimeters. So they're saying this whole diagonal right here is 8 centimeters. And they're saying that, and MZ, which is right here, is equal to 3 centimeters. in length. Give a length for the following segments. Well, we can see WM is going to be half of WY. Okay, and WY was 8, so half of that would be 4 centimeters. Now MY is the other half, so that's going to be 4 centimeters because that total length of WY was equal to 8. On the next one, it says XM. Well, XM is going to be half our total length. And they said WY was, XM, there it is. XM, they said the total length of it, or MZ, was 3 centimeters. So that means it's the other half of it would be 3 centimeters. So that's going to be XM here, which would be 3 centimeters. Because the total has to be 6. And that means that YZ, which is the total length, would be 6 centimeters. For using properties of shapes, explain why all parallelograms are trapezoids. Well, this is where you have to go back to what it means to be a trapezoid. And we know for a trapezoid, because we're using the inclusive definition, means at least one set of parallel sides. So a parallelogram, all parallelograms all of them have 2 sets of parallel sides. And since they have one set, at least one set, that means all parallelograms are trapezoids. That's using the inclusive definition. Okay, this question's already been done for us. Well, I want to sit there and exaggerate just a little bit further and saying, because both diagonals do not have to be the same length. And I'm going to exaggerate a problem just to show. And I'm going to use a rhombus in order to do that. So I'm going to try to draw as good a rhombus as I can, but it's going to be freehand. But I'm going to exaggerate it, okay? Okay, there's my rhombus, okay? Now, let me try to change the color here so we can see it. Now, notice in this one here, here's one diagonal between 2, and here's one between this one. And you can see clearly that this diagonal is a lot larger than this one is. And that's because the angles that they're coming from are acute. And this one here is obtuse. So, since the angles that are obtuse are opposite each other, then that diagonal is going to be shorter. Now, where they intersect right here